Okay, so last time we learned how to solve by graphing. Today we're going to learn another method of solving. It's called substitution. This does not involve graphing. It's an algebraic method of solving. And in addition to this one, there's a third method called elimination, which we're going to see next in the next class. So let's talk about the substitution method today. So again, so this is the substitution method. So last time by graphing, to review this quickly, by graphing, when we had a system of two equations, for example, this and some other equation. Okay, so this is what makes a system. It's two equations, system of linear equations. Each one is basically a straight line. Straight line together, they form a system. Okay, so this is a system. And solving the system meaning finding whether these lines intersect or not, and the intersection basically of the lines is a solution. Okay, so that the solution to a linear system is see the behavior of the lines on the same graph when we did by graphing. So the lines, as we saw, either intersect. In that case, we have one solution, the intersection. Sometimes the lines are parallel, they don't meet at all, so no solution. Or sometimes the lines overlap. So you grab the first line, then you grab the second line, for example, and it ends up overlapping with the second one. So this is here we have one solution, here we have zero solutions, and here we have many solutions. Okay, so that's the method of graphing. But today we're going to pretty much do the same thing, but without graphing, just by doing some solving on some algebraic steps. So let's take a first example. So basically when you have a system, let's take a system like this, say x plus y maybe is 3, and another equation maybe this. Okay, it's a simple system like that. So let's solve this by substitution. Okay, by substitution, not by graphing. And first we need to understand, so substitution means to replace something, substitute something with something else. In terms of linear equations and systems, what we mean by that is you basically go to one of the equations, usually the one that has a variable by itself, for example here y. You take that variable and you substitute it in the other equation. Okay, so you go to the equations, you look for the variable that's by itself on one side, either x or y. You take that and you replace the same variable in its equivalent in the other equation. Once you do that, you'll end up with an equation with just one variable instead of x and y. Once you plug this here, you'll have x plus 2x equals 3. So it will be an equation with one variable, which is easier to solve instead of two variables. So we're going to call this equation. So this is equation 1. This is equation 2. Okay, so plug or substitute y in equation 1. So this one's by itself, so we're going to substitute the y in equation 1. So let's rewrite the equation. So equation 1 turns into this. So x stays plus the y. So we're going to remove the y. We're going to replace it with 2x because it's equal to that. It will be 2x here. So instead of y, the 2x, then the rest of the equation remains the same. As you can see, that's a simple first degree equation. We can easily solve it. Okay, so x plus 2x, that's 3x equals 3. We divide by 3, that means x is 1. So that's half of the solution. So again, when you solve a system, when it's one solution, for example, it's a point. It's a point of x and y. So the solution to a linear system is a point or many points. So it's a pair of points. The solution has to have x and y. Okay, so far we found x, that's 1. So the second part is to find the other variable, to find y. Okay, so find y using x that we just found. So when we find one of the variables, it helps us find the other one. So there's 2 steps. Okay, find one variable, then use that variable to find the other. So we substitute this here, we solve this, so now we have x, okay, but we're still missing y. So to find y, we're going to use one of these equations. Usually one of them is more convenient and easier than the other. So since we're looking for y, so this one already has y by itself. We just need to know the value of x, which we do. We just found it. It's 1. So we're going to plug x here, 1, and then we can easily find the y. You could have used this one as well. It will lead to the same solution. Okay, but it's easier. It is easier to use this equation as opposed to this one. So if you're looking for y, look for the equation that has y by itself already. If you don't have one, then you can use either one. Okay, so I'm gonna plug x. And equation 2. Again, because it's convenient, so y would be, so this is the equation 2, 2x, y equals 2x, so y is 2 times x. X again being 1, because we just found it from here. And that's it. Once you find your 2 coordinates, so 1 and x is 2, x is 1, y is 2, and that's it. So the solution is you can call it S, it's a pair, 1, 2. Okay, so that's the whole idea of solving linear systems by substitution. We're going to pretty much be repeating the same process. Sometimes there might be some extra steps, but that's the whole idea. So you look at the system, you go to the variable that's by itself, and you take that variable, you plug it into the other equation. It doesn't have to always be y, it could be x here, could be x here by itself, you plug it into the equation. Once you plug that, you end up with a simple first degree equation, which you solve to find one of the variables. Once you find that variable, then you need to find the other one. You find the other one by plugging this in one of these. It doesn't matter which one you use, either one will be fine, but usually look for the one that's already convenient or has the variable you're looking for by itself. Okay, so once you plug that variable into one of the equations like this, you find the other variable. So the system, again, could have one solution when the 2 lines meet. If the lines are parallel, when they have the same slope, they never meet, therefore no solution. So you will end up with something that doesn't make sense here. When you end up, for example, with, I don't know, some contradiction 2 equals 5 or something like that, that's how you know your system is not, doesn't have a solution. But we'll see some case like that later. So either one solution, one solution, no solution, or many. It's possible also to have many solutions. We're going to see a case of that later. Okay, so in this case here, which case is it from for this system? Which one is it from here? Is it the first one, second, or third?
The first one.
Exactly, it's the first one because it's exactly 1 point. It's this one. Okay, let's try to do another example. It's always going to be the same main steps. So if we take another equation, let's take another equation here. So let's say x minus 1 minus y. And the other equation may be 2x plus 5y equals 7. So again, that's our system. We want to solve it by substitution. Let's call this equation 1. Okay, and so what do you do first to solve this by substitution? We try to follow the same steps here. So what do you plug and where? So we need to substitute. So which one do we substitute? Which variable needs to be substituted in this system? If you look at this here, again, we look for the variable that's by itself, and we plug it into the equation. But for here, which variable do we substitute? Again, we look for the variable that's by itself. So in this equation, in this system, which we do just by itself. So we'll see x is already by itself. Okay, so we're going to take the x and I'm going to plug it into the x in the other equation. So that's how substitution works. It has to be one variable by itself. Could be either variable in either equation. You take that variable, you plug it into the other equation. Okay, so again, same step here. So substitute x. This time we're going to plug it into equation 2. X, substitute here. And equation 2. So this is equation 2 here, so it'll be 2 times x. So instead of writing x, I'm going to write this because x equals that. So remove the x, substitute it with -1 minus y. And the rest of the equation here, equation 2, remains the same. Only thing we did was remove the x and substitute it with what it's equal to, which is -1 minus y plus 5y equals 7. Then solve it. As you can see now we have an equation with y only, not x and y. That's the reason we substitute, so we can get rid of one of the variables and have the same variable and solve the resulting equation. It's usually simpler. So let's solve this equation. First we distribute. So -2 minus y plus 5y equals 7. Okay, I'm going to combine like terms here. -2. We have -2 plus 5, that's positive 3y. And 7 minus 2 minus 2 on both sides. So again, we already know how to solve first degree equations. So these cancel out, 3y, and we have 5 here. Okay, so -2, 5, and finally, y is 5/3. Okay, so that's, we just solved for one of the variables. So what do you think happens next? So y, actually this should have been, to make things, this is actually a 5 here, not a 3. 5 should be a 5y. I don't know why I wrote 3. To make things more convenient. Okay, so 5y, 5y. So this 5y moves here. Okay, now we divide by 5, divide by 5. So y is 1. That's half of the solution. We have one point, but we still need to find the other one because when we solve the system, we need a pair, x and y. So this time we found y first. Again, it all depends on which variable is by itself. So you don't have to find one first and then the other in a specific order. We look for the one that's by itself. Okay, that's the first step. We have y1. What do you do now? What is the next step in solving this system?
plug y in equation 2?
Exactly. We'll need to find x. So we have 1, or y, which is 1. We still need to have need to find x. To find x, this is x. It's equal to -1 minus y. Luckily, now we have y, so we're just going to plug the y here. Substitute it here, then we have our x. So find x, so plug y1 into equation. This time it happens to be equation 1. It's more convenient. You could use this one as well, but this one is already has x by itself. So you don't want to use this one because you will have to eliminate this and then eliminate 2. So this is convenient. So then plug it into equation 1. So x would be -1 minus y. Again, we found y to be 1. So x is -2. Okay, so we have both x and y. We can write them together. We usually say S for solution. Start with the x first, and then the y coordinate. And that's pretty much how you solve linear equations using substitution. So there's one thing left to do. We could have made a mistake here. So we need to check our solution. We can't rely on this. We have to see if this actually works or not. And we do so by taking this pair and we're going to plug it into this and see if it works. So it has to work for both of those. If it doesn't work for both of them, then that means we made a mistake here. We need to double check it. So let's see if this works. As we saw previously in a previous lecture, in order to find out whether a pair is a solution to a system, we need to plug that pair in both equations, and it has to work for both in order to be a solution. If it doesn't work for both equations, then it's not a solution. So that's our system again here. Let's write it down again. So we have x minus 1 minus y. And we have 2x plus 5y. So our solution, or our proposed solution, we don't know if it's actual solution yet, is this, but is it valid? So let's check. Or let's plug this in equation 1. So this is again x and y. So we're going to put those here into the equation. So x is here, -2, equals -1 minus y. Minus y. The y is here is 1. We say is that equal to? Yes, in fact, -2 equals -2. So that's good. So this point, or this pair, is a solution for this one. But in order for this to be a solution to the entire system, it has to be a solution for this one as well. If not, then it will not be a solution. It will not be a common point of intersection between the two. It has to belong to both of them. That's why we check to make sure the point belongs to this line and the other. So far, we worked for this one. That's good. Let's check the other one. So now we're going to plug in equation. So this is equation 1. Then we have equation 2. Let's plug that here. So again, it's 2 times x, or 2 times whatever the x is, plus 5 times y, equals 7. 2 times, what is x again? What x are we trying to plug here?
-2.
That's right, the x is here, is -2. And y is
1.
1, right? We say, is it equal to 7? Let's find out. 2 times negative 2 times negative 2, that's negative 4. Then we have 1 here. 5 times y, so it's 5. And again, we say, is it equal to 7? This is 3, which is not equal to 7. So there is something wrong here. So again, this is supposed to work for both of them. So it worked for the first one, it did not work for the second one. It means there was a mistake made here, because when we solve, you should get either one solution, many solutions, or none. So it didn't work with the second one. Let's check, maybe we made a mistake when we plugged it. So here's the second. Is the what is the second one? So the second equation here. So after we plugged, so there was a mistake from this step to this step. Can someone tell us what the mistake was? Look closely at that equation. There is a mistake here. Can you guys see it? Okay, so if you can't see it, so we have 2 times negative 1, that's negative 2. 2 times negative 1. That's actually, it's fine. This step is fine. Then you have plus 5 in this. Okay, so the mistake is from here to here. Actually, not from this step to this step. What do you think the mistake is? What do you think?
Minus 2y plus 5y.
Should be?
It should be 3y.
Exactly.
Yes, 3y.
That's right. I think it was initially, I changed it, but it was.
Yes, you did.
Yeah, it was correct initially. I was thinking about this coming here, but okay, so let's go down the steps and fix the rest. So we have this and this. And there's another mistake here from this step to this step as well. What is it? From here to here, or this should not be negative here. We have negative 2. To cancel it, we need a positive 2. Also here we need a positive 2.
Positive 2, yes.
Okay, so that way these cancel out. And now this turns into a 5. This is still a 3, right? So this has to be a 3.
And the other one turns to 9, right?
The other one, let's see. So hopefully now we got this right. So 3y got 2, 2. That's a 9 exactly. So one mistake can trickle down and make everything else false or incorrect. Okay, so finally, if you divide by 3, so y will be 3. Okay, so hopefully now this should work for the second equation. Again, your solution must work for both. If it doesn't work for both, then it's not a solution. But here, when we solved, we were looking for a solution, so we should have a valid solution for both. So let's now check. We're going to check here this second step. So plug.
I lost the connection, Professor. Sorry, I'm at home.
Okay. So we have this, check the first one. Okay, so that works. Now the y is 3. So we should change this to 3. Okay, we already checked the negative 2. That's good. Let's actually redo the whole thing because now we have x and y both have to be plugged. So let's check the whole thing again. Let's just recap what we did here. So again, we just substituted this here, and we solved this to find y. Now we have to find x. Okay, so we're gonna find x using y. Again, which equation is convenient to use here to find x? Is it equation 1 or equation 2?
Equation 1.
Equation 1, that's right. Already has x isolated. I'd rather use this. If you use this one, it's gonna be some extra work. So plug y3, this one here, in equation 1 to find x. Equation 1 to find x. So that's equation 1. So let's say x is -1 minus 3. X is -1 minus y. Y, we have it. We just found it. It's this. So, or we can put it right here. Okay, so again, this is some proposed solutions. We don't know yet if this is the accurate solution. That's why we need to check. So far the solution seems to be x -4 and y3. But is it correct? We don't know yet. So that's the purpose of checking the solution. So we're going to take our solution and we're going to plug this into both equations. Okay, check equation 1. So we're going to take this, we're going to plug it into this. So again, this is x and y. I'm going to plug into the equation that x is -4 minus 1 minus y. Y is 3. Is it equal to, let's see, so -4 is in fact equal to this side, which is also -4. So that's good. So the equation worked for this, the solution worked for this line, the first one, but it's not a solution yet to the system until it works for the other one as well. We have to get something that makes sense like this, not some contradiction like we did earlier. So check equation 2. Okay, so check equation 2. So we're going to take this equation, we're going to plug these into it. So it's going to be 2 times. 2 times what? What is it? 2 times?
X,
Which is?
which is 2x.
No, we need to plug. We need to substitute to check the solution.
It's -4. It's -4.
Times x. X is here is -4. Then 5y. 5 on the y is 3. So we're tracking the solution, so we plug in these into both of these. Is it equal to 7? We don't know yet, so this is -8 plus 15. And we say, is it equal to 7? What's -8 plus 15? -8 plus 15 is in fact 7, which is equal to this other side, 7. So that works. So what do you say about this pair now? Is that a solution to the system? Is this pair a solution to the system?
Yes, it is.
It worked for this, it worked for this. So now that's the right solution. Again, if you end up with something that doesn't make sense, you gotta go back and backtrack your mistakes, okay? Check your mistakes, check your signs, because when you solve a system, the solution has to work for both equations. Otherwise, there's something wrong. So that's basically how you solve, or how you solve linear systems by substitution. Okay, the method of substitution, not graphing, not some other method. Okay, so now let's see another case. we're going to see another case of solving linear systems. So far, again, you look at the system and you look for the variable that's by itself. You plug it into the other equation. Same here, we'll look for the variable that's by itself. That's what you substitute in the other equation. But sometimes you may not have one variable by itself. So, for example here, let's say x minus y is 3, and maybe x plus y is -1. So that's a system. We want to solve it again by substitution, not some other method. But we don't know what to plug and where. We don't have a variable by itself. We don't have x by itself or y by itself. So in this case, we have to isolate one of the variables. You have to get one of the variables by itself, either y or either x. In either equation, doesn't matter. So you can isolate. This one does not have a variable by itself. So we need to isolate one of these. It doesn't matter which one you isolate. Just look at the two equations and try to get one of these by itself. So in this case, maybe move this over here. Okay, so we're going to move the -y to the other side. That way we can have the x by itself. Or you can move another one, maybe plus y. You can move that to this side, or you can move the x. It doesn't matter. So isolate one variable. So if you move this -y over, the system turns into x. -y turns into just y plus 3. Then we have this one, we have x plus y is -1. Okay, so again, it's up to you to choose one of the equations and one of the variables to isolate. So this one moves over. Okay, and now that we have one of the variables by itself, what do you think we do next? Again, we're trying to solve this by substitution. So after isolating one of the variables, what happens next? Everyone, we're going to do the same thing as we did before. So what do you do now? Which variable do we substitute and where?
We start from the second equation.
Well, so which variable do we substitute? So we have equation 1.
X.
That's right. X. Always the one that's by itself. That's what you plug in the other one. Just like here, we had y by itself. We plugged it here. Here we had x by itself. We plugged it. And here we didn't have 1 by itself, so we had to isolate. It's up to you to isolate 1. Just look at the two equations and see which one is easier to use to get one of the variables by itself. Basically, you kind of like solve it for that variable. It has to be by itself without a number here. For example, if you had 3 here, for example, 3x, there was a 3 here. Then after that, you're going to have to divide by 3. So now we're going to plug this into this. So plug or substitute x in equation 2. So this is equation 2. We're going to take that x and plug it here. So it'll be x. So instead of x, we're going to write y plus 3. And equals. So here we have x, which is y plus 3. The other side we have y, which is y plus 3 as well. Actually, we plug into equation 2. So this goes here. Means you're going to take this, remove it. Instead of this, we're going to write y plus 3. Okay, then the rest of the equation remains the same. Only substituted this, we'll remove the x, replace it with this here. Then we'll bring down the plus y and the minus 1. So we have 2y here. plus 3 negative 1. Okay, combine like terms. Then we subtract, here. So 2y is negative 4. If we divide by 2 on both sides, y is negative 2. That's the first step. Again, we're just repeating what we did earlier. Now we have y. What do we do next? After finding the y,
We plug it into equation.
exactly. So we need to find x. Which equation do we use to find x? So we have y. That's part of the solution. We need to plug this into. Which one is easier to use to find x?
The first one.
That's right. This one already has x by itself. So x is y plus 3. So the y is here. Instead of y, we're going to put negative 2 plus 3. So x is 1. And that's your solution. You can write this as a pair of, as a point. So 1, always write the x first, comma, negative 2. And that's it. And don't forget to check it, just like we did earlier here. Make sure it works. So if you plug it in this original equation, so you have to plug it here, and make sure it works for both. It has to work for both. If it doesn't work for both, then you have a problem here, just like we did earlier here. So you have to double check and make sure you don't have any mistakes. Okay, everybody, does that make sense? Any questions?
No questions, Professor.
Everybody else, you guys on board? I don't hear from you. Class, are you guys there? All right, seems like you're not here for some reason. Seems like I'm talking to one person only. And that's pretty much how you solve linear systems by substitution. Let's do one more example actually. So let's say you have 2x minus 4 is 8, and maybe probably plus so you may have something like this. You could even add some numbers here. So that's another system. We want to solve by substitution.
Professor, I've been here. Sorry, as I told you, I was outside. Sorry, I couldn't get connected. Sorry.
All right. So now we have another system we want to solve by substitution. What is the first thing we do? Again, quite similar to this one here. So what do you want to do next? Again, the purpose is to solve by substitution. So can we substitute something right away here? Let's add, we need some variables here. So we don't have a variable by itself. Again, we don't have one like this by itself or here. So we have to isolate one. Yeah, take one of the equations and isolate one of the variables. And again, it doesn't matter which equation you take. Either one would be fine. To isolate one of the variables, let's maybe take this one for example. So isolate, they look about the same level of difficulty to isolate, or the number of steps. Either one will be fine. So let's take this one here for example. This time we can choose whatever variable we want to isolate. Usually we try to look at the equation and see which one is easier. But for here, let's maybe isolate y this time. So earlier we isolated the x. We got the x by itself. Let's try to isolate y in this equation. So it's like solving for y. So isolate y in an equation 2. Again, this is optional. You can do it in either equation. Just look at the 2 and see which one it looks easier to you to use. So let's take that equation. -9. And again, we trying to isolate this one. So it's like solving this equation for y. So to solve this, so we're going to cancel this whole thing from this side. So we're going to subtract it. Or you can just move it to the other side and change the sign. Okay, it's probably easier to do that way. Okay, so we're going to move this over across the equal sign, and the sign will change. So this stays here, 6y, positive 6y, equals 3x turns into negative 3x. And bring the -9 down. Now we're going to divide, because we want the one variable completely by itself. The y is not by itself yet. We have to divide it by 6. Also divide it by 6 and the other side. So those cancel. So y is, we reduce this, would be negative x over 3 if we reduce that. Minus, we can also reduce this by 3, it would be 3 over 2. That's one step. So this system turns into a new system like this. So 2x. And the new equation, so we're going to use this one instead. So the equation 2, we turned it into this because we wanted to get one of the variables by itself. So y is negative x over 3 minus 3 over 2. And after that, the same process begins. That's the important part, is to isolate one of the variables. Once you get it by itself, now we do the same thing as here. We plug the variable here, then find x. After that, because once you plug y into this, the y will go away. You will have x only, this x and this x. Find x, then find y. Okay, so pretty much just like here, plug them, and then at the end, you check your solution. So that's pretty much all about solving equations with substitution. It's the same, again, same process every time. Plug one variable into the other equation, find one variable, then find the other. If you don't have a variable by itself, you need to isolate one, okay? Solve either equation, get one of the variable by itself. Once you do that, you find the first variable and then find the second one. And of course, don't forget to check. Okay, everybody, does that make some sense to you? Any questions?
No questions.
Okay, again, this is related to the previous lecture or lectures, so make sure you have seen those before you can grasp this. So watch the last couple of lectures on lines and systems, because that's related to this. I will, of course, post this lecture, so make sure you rewatch it before you do the homework. And also post the homework for this soon, probably later today or tomorrow, so we can rewatch this lecture. And if you have any questions as you study, as you do your homework and study the lecture, please write them down and let me know during our next class, or you can email me if you need some extra help or tutoring, or you can also contact the Learning Center for help.
Okay.
All right, so let's take some attendance.